All right, chapter 9 is on transformations. Remember specifically isometries and rigid transformations. Hold congruence, hold measurement. They are rigid. So therefore, in 9.4, when we talk about compositions of isometries, we are doing more than one isometry. And in this case, if it's an isometry, again, we're moving things, but we're not changing measurements. We're not changing length or angles. That might not be so reflective in this particular first example that I have right here, but let's look at it. First of all, as I look at the notation, this might be read as the reflection over L2 circle the reflection over L1. The weirdest thing about this is that circle function does not allow us to read it from left to right, but instead from right to left. I'm going to reflect over L1 first, and I've done that in the picture already. See where U ends up at U prime. But now, as I reflect over L2, U prime now is going to end up right here. Finally, an observation you might want to see here. The distance between these two lines of 5. Notice the distance between U and U prime, 6, 3 and 3. And the distance between U prime and U double prime, 4, 6, 4. It's double the 5. 2 times 5 is 10. It really moved 10. It's going to move twice the distance when those lines are parallel, which you see right there. I wonder when that composition is not of parallel lines, but lines that intersect. First of all, notice again the notation, reflection over M, circle, reflection over L. But if you read the descriptions, if you're wanting to read the paragraph above there, they would also suggest that you're going to reflect over L first, and then reflect over M. Let's do it, and let's see what happens. Here's my attempt at reflecting over line L. Now let's reflect over line M. So the blue figure is my final figure. Now there is a relationship here that happens as well. When you reflect over two lines that intersect, the reflection turns out to be a rotation. The composition of reflections turned out to be a rotation equaling 2 times the angle, the acute angle of intersection. Therefore, the angle that I'm making, if I look at the vertex of that V, should be 118. Again, repeating the concept. A composition of reflections, reflecting lines that intersect. You're going to multiply or double the angle created by the two lines. Another common composition of isometries is what we call a glide reflection. Glide, meaning we're going to do the slide or translation first, and then we are going to reflect over a line parallel to the motion of the translation. Within the notation above, you can see that circle function again. So we're going to reflect over y, circle, translate, -1, 0. Well, we have to translate first. Again, just like the others, we are going to go and read this backwards. I'm going to move everything over left 1. The blue points represent moving over to the left 1. Now I have to reflect over the line y equals 0. Well, that's the x-axis. After reflecting those points, you'll find the new home for E, T, and X like this. There is our figure after a glide reflection. Let's wrap up with a reminder. Transformations do not have to be rigid. Isometries will be rigid transformations. Those shapes that we move will remain the same size and shape. The orientation may change because we flipped or because we spun the figure around, but the shapes will remain congruent.